lecture with you also, the actual, just the lecture, not this whole recording. I always share the recording too, but sometimes it's easier just to look at the video lecture. Okay, so here we are with net forces and how to solve net force problems. Just watch this. I'll try not to pause it too much so you have more time to work on the problems. But I think if you pay attention to it and you work with me when we're done, we should be able to get through the first couple problems.
Due to friction. They will be able to identify and calculate anti-parallel forces due to lifting against weight, and then calculate net accelerations caused by these net forces. We've been here before. We know that net force, F net, is a resultant force, the sum of all forces acting on an object, and in its final form, Newton's second law says F net is ma net. Well, what is net force? All net force problems start the same way. F net is F1 plus F2. But
all right, so remember when you're finding the net force, you're adding all the forces up. But if you have force 1 here, this is actually m times a. Force 2 is m times a, because we know that the formula to find force is F equals m times a. Now, don't forget, because we're gonna look also at the force due to gravity, which is your weight. Don't forget that that acceleration is 9.8 meters per second towards the Earth. Okay.
Which forces are positive, which forces are negative, and what is the sum of these forces? So, forces in a net force problem. What negative forces are there in the net force problem? Well, there's a couple. First of all, weight is a negative force. Remember, mass and gravity. F sub g is mg. It's negative. Why? Well, it's negative by convention, meaning a long time ago, a bunch of physicists got together and they ordered a bunch of pizza from Domino's, and they were sitting around with pizza and Mountain Dew and said, hey, which way is down? And they all said, down is negative. So by convention, down is negative, which makes weight a negative force because it always acts down towards the center of the Earth. What other negative forces are there in a net force problem? Well, friction, the great robber, it always tries to stop motion. So as a force that opposes motion, the force of friction is mu times the normal force. And it's always negative. Well, what's mu? Well, mu is the coefficient of friction. It's a different number between whatever surfaces are on contact, and F sub n is the normal force, the perpendicular force. So other forces that appear in net force problems, positive forces like tension, the force transmitted by a rope, chain, cable, or string pulling something upwards. Other applied forces, which can literally be pretty much anything else they can think of. The force of a rocket motor, the force of the airplane wings, the force of engine bolts holding an engine into a car. So the force applied by any of those is positive because they are fighting against weight.
Okay, so listen, don't get confused with all of these different things that he's talking about. Really, with the problems today, we'll work with the force of weight, the force of gravity, pulling you down towards the Earth or pulling something towards a scale. And that'll be negative, so subtracting when you do the net forces. We will also work with the force of friction, but with that force of friction, we will give you the negative force dealing with friction and not having to use that coefficient. When he talked about the coefficient, that's just saying that the force of friction changes depending on the surface. The floor in my classroom would have less friction than the carpeted classrooms in the new building. The cement outside would have more friction than when it's ice-covered street. So that's what that mu is and how the coefficient changes.
Well, let's look at several of these problems. We know that the net force, or the normal force, is the perpendicular force acting on a surface. And this enters into friction and drag problems. And a parallel force is the force pulling an object down a hill. Well, let's take it out for a test spin and see what will happen as we identify the anti-parallel forces, net forces due to friction. Consider for a moment moving one of these. These guys are involved in a huge friction problem. They practice on this. Yeah, all of us who have spent time on a football field, especially the big guys, know what this is. It's a blocking sled. And it's used for conditioning, strength, timing, and speed for the offensive lineman. It works like this. The offensive lineman, in this case, all of them 6'6" and 330-pound weightlifters, apply a force to a blocking sled together to move the blocking sled. The force applied is in one direction. The force of friction acts in the other. Are there other examples of friction problems? Sure, here's another friction problem. That's a pretty good job by this Chevy climbing up a wall. It's held there by the force of friction. Weight will try to pull it down that cliff. Friction pushes the other way. So how does this work? Well, for friction problems, remember, all net force problems start the same way. F net is F1 plus F2. Or in this case, we have the net force is the force applied plus a negative friction.
Okay, so when you look at the formula right here, he's mentioned several times they all start the same way. The forces are added together. But when you do the problems today, you're going to have to plug in the actual forces for the F1 and the F2. And remember from the beginning of the lecture, we talked about friction force being negative. So really, when you set this up, it'll be the applied force minus the friction force, and that's how you find the net force for that. The applied force, so go back to the lineman blocking on the blocking sled, the force they're applying in one direction, and then you subtract the friction force going in the other direction. So it's a simple subtraction problem when finding the net force dealing with friction. It'll be the same thing when finding the weight dealing with gravity, because that's a negative force also.
Because friction's always negative. Well, we could jump one more step and say that F net is the force applied minus friction. And we know that Newton's second law says F is ma. So ma net is equal to the force applied minus friction. So friction problems.
So listen, same thing. Don't wet your leg when you see these different formulas here. All we did is we're taking the actual formula for force, which is m times a. So the net force is actually m times a net, which equals the applied force minus the force of friction. And then you can solve for acceleration by dividing each side by mass. Or you can solve for mass by dividing each side by acceleration. So that's why I only want to do a couple problems today, because I want you guys to be able to ask questions and work through it before, instead of throwing 7 problems at you and having you confused.
When it comes right down to it, ma net is the force applied minus friction. Now, you can go one of two ways when you solve for the net acceleration. You can do this in one step. You can start here and move mass to the other side. With a little algebra, you end up with a net is the force applied minus friction divided by the mass. Or you can make it a little easier and do it in 2 steps. You subtract, then divide. F net is the force applied minus the friction. And after you have that, Newton's second law says F equals ma. So A is F over M, get you your acceleration. Both are correct. Which one works? Well, we'll be concentrating on the two-step approach for now. Let's look at our next. Identify and calculate the anti-parallel net forces due to lifting against weight. Well, what kind of problems do we have where we're lifting against the weight? Well, they can appear in something like tension and weight. In this case, a crane offloading cargo from a ship. Now, this guy really knows what he's doing. That's a $30 an hour job. Because if you don't know what you're doing and you miscalculate the weight and tension in that crane, well, then bad things can happen. Imagine calling your boss and telling him, hey, boss, got a little trouble with the crane. Or this one, where he dropped the crane on the building. And if you look carefully, this is the counterbalance. So the cab is here pointing this way. The boom arm goes at an angle, which can only mean he's got to make the call that says, boss, I broke your $1 million crane. So tension problems, and these people know what they're doing, involve a tension in a wire picking something up that has a weight. So does one of these. That's an Airbus A380, the largest commercial aircraft on the planet. It is actually a 747 with another 747 on top of it, and 4 of the largest jet engines Rolls-Royce can make. In fact, compare that to the guys and the truck in front of the plane. If you're to work on that engine, you have to get inside the engine. So there's the center of the engine. This guy is 6 foot tall. So that's a 10-foot diameter jet engine. Well, that'll apply some force, but we want to know about the force picking it up, or the forces in the wing. So weight and some applied force problems. What kind of something else for an applied force? Well, it could be anything. It could be tension in the cable, could be the motor, could be the aircraft wings, could be the rotors on a helicopter, could be anything. Well, all net force problems start the same way. F net is F1 plus F2. One of those is positive, one's negative. And by convention, down is negative, so weight is negative. I could just jump to F net as the force applied minus the weight. Or I can do it in one step by remembering Newton's second law. Ma net is the force applied minus the weight. So with this, again, there are 2 ways we can go. We can take Ma net as the force applied minus the weight, and in one step solve for the net acceleration. Just a little bit of algebra, take mass to the other side, and I have the net acceleration is the force applied minus the weight divided by the mass. There is a slightly easier way. I could do it in 2 steps, where first you subtract and then divide. So F net is the force applied minus the weight. Once I have the net force, well, Newton's second law said net F net is Ma net. So with a little more algebra, I have that A net is the force applied divided by the mass. Both are correct. For now, we'll be concentrating on the 2-step. Now, remember as you do these weight problems, weight, F sub G is mg. If you read the problems and they tell you that the box you are picking up has a mass of 100 kilograms, you have to find the weight. Well, you substitute mg wherever you need to calculate weight in your problems. You know me. Let's take it out for a test spin, see what happens. Whenever I have a physics problem, the first thing I have to do is a force of 1,200 newtons lifts an object with a mass of 100 kilograms upward. Determine the weight of the object, the net force, the net acceleration.
Okay, so listen, use your calculator and then type it into the chat if you don't want to buzz in, or you can just buzz in. But all of the problems that I have you do today will be set up just like this. So the first thing I want you guys to do is find the weight of the object. Remember, the weight is mass times gravity, or mass times 9.8. So everyone find the weight of the object using a calculator. The mass is 100 kilograms. Gravity is 9.8. And either type it in or turn your mic on and tell me. I'll give you 10 seconds because I've already figured it out.
Is it 980?
Yes, good job. How many were thinking 980? All right, looks like a few of you guys were. All right, good, good. You don't have to keep typing now. That was good. So the weight is 980. So everyone can do that. Now, the net force is force 1. Let me pull this back up. The net force is force 1. And remember, because it's a weight, it's going to be a subtraction problem. So everyone find the net force. That'll be this force minus 980. Let me put the givens up. Here's the first part. Here's the first part. Now you're going to find the net force, which is this force, force 1, minus 980. Do that and type it into the chat. I'll give you 10 seconds because I've already got it. Good. Nice job. Nice job. 220 newtons for the net force. And then the third step is finding the acceleration. And that is just taking that answer, 220, and dividing it by the mass. The acceleration is taking that 220 that you just got and dividing it by the mass. Everyone do that and type it in. Good job. All right, nice job. And that's how all of the problems are set up today. Let's do one more example. And there it is, the 220. Let's do one more example.
Net acceleration of 2.2 meters per second. Now what? Let's look at another. Whenever I have a physics problem, the first thing I have to do is an object with a mass of 25 kilograms is pulled across a flat table by an applied force of 125 newtons. A frictional force of 12.5 newtons acts on the object. Determine the net force, the net acceleration. Well, read it. After I read the force, read it.
Okay, so listen, try this one right here. You're going to determine the net force. Remember, the net force is F1 plus F2. Here is your force of friction. So again, it's a subtraction problem. Here's your applied force. The friction's in the opposite direction. So everyone do this one. It's going to take the applied force and subtract the friction force. Ah, darn it. Don't look at that. Type it into the chat. Again, it's the applied force minus the friction force for the net force. Give you 5 seconds because I've already got it. Someone type it into the chat. Nice job. Nice job. Cole, Brooke, Haley, that's good. Okay, so now let's find the acceleration. Let's find the acceleration. We're going to take the net force and divide it by mass. So take that answer, 112.5, and then to find the acceleration, that's force divided by mass. Okay, do this one. Do this one. Hey, nice job. You guys are ahead of me. 112.5 divided by 25. And that is correct. 4.5 meters per second squared. Okay, I am going to stop recording.